Hi, this is Stephen Brower from Rat Valley Community College. This demo is meant to accompany Irvine Chapter 8. And there are two demos that I want to look at. The first one I want to look at is this demo register proc. What it does, the approach that it uses for passing parameters is what we've been doing with the Irvine library, in that some registers are loaded and we call a procedure. Some registers are loaded, we call a procedure. But what this one does, this is a procedure that we wrote, or that I've written here, this get deck from user. And in terms of the input, it's showing these are the inputs it expects, meaning these two registers, and then this is the use of those registers. And what I tried to do, we'll see if this works, is I tried to animate what's happening in memory, showing the parameter use. So imagine this is the code segment here. This is the procedure that's defined. This is the data segment. And so we're about to step into this first statement. So this statement here loads EDX with the offset of the length prompt. Length prompt is here, and so EDX, and you can think of logically as like it's an address, but EDX is going to have the address of that. And then next thing here, EDI, we're going to load it with the offset of length rectangle. Well, length rectangle is this D word right here that's currently uninitialized, and so EDI is going to have a pointer to it. Then we call the method, the getDeck from user. So we come into the method, and when it does this write string, it's writing what, or the string that EDX is pointing to. So this will, in this case, display the length prompt. Then readDeck is going to get what the user inputs and leaves it in EAX. So after this readDeck is done, EAX is going to have what the user enters. And what this statement is going to do here, it's going to take EAX, which currently is the value 12, and stick it into what EDI is pointing to. Well, EDI is pointing here, so it should overlay the unknown with the value of 12, and that's what's being shown here. This procedure is now done. It returns control back to main. So for the Irvine library that we've been using up to this point, we would load some registers, call a procedure. So this method for using registers as parameters, it would just be the procedure written itself is assuming that those registers have values. And there's a slide in the Irvine slides that shows for even in 64-bit, there is a recommended for the first 4 parameters to use certain registers, and then after that you start using the stack. So I'm going to take the same example with this getDeck from user, and I'll show it instead using the stack. So getDeck from user is being called here. We're going to push some things onto the stack first. Now I don't have a value here, so initially right now the ESP of the value that's here is unknown, but this would be the top of the stack. And the reason why I'm showing it this way is, remember, it's like an upside down stack, in that as things get pushed onto the stack that it will move down. This down here is the procedure that's going to be using the stack, and we'll get into the details of that in a moment. So first thing, we're going to push onto the stack the offset of length prompt. Oops, sorry. We're going to push onto the stack the offset of length prompt. So what will be on the stack at this point right here is a pointer to length prompt. Then we're going to push onto the stack the address of length rectangle. So now this part of the stack is going to be pushing, going to be pointing to this D word, the length rectangle. If you notice, the ESP has been moving. This is the stack pointer. And so as things are added to the stack, it actually is, well, decrementing in terms of value because of the upside down nature of it. When a call to a procedure takes place, one of the things that's put onto the stack is the address of where this call statement was, meaning when the procedure is done and we come back, where do we come back to? So what I'm doing here is to sort of illustrate that on that call, what's put in the stack, when we do get back to this point, in other words, when our procedure is done, we're going to be going to the statement that's after here. Now, since we're using the stack, we have to actually show what goes on in the stack. The uses statement, behind the scenes, what the uses statement does is it'll push these registers onto the stack, and at the end, when the procedure is done, it pops those registers off to the stack. So if there's values in there, now I'm not showing in terms of the slide EBP, EDX, and EDI, but I am showing EAX. So if these four things are pushed in order, 1, 2, 3, 4, then these four things get put onto the stack. So whatever was an EBP got onto the stack, whatever was an EDX got into the stack, whatever was an EAX, which is currently 42, meaning of life, went into the stack, and then whatever was an EDI went into the stack. So the stack just has a copy of those registers, of which EAX is one of the registers. Now, instead of us in the code directly referring to ESP, what we're going to do is we're going to make a copy of ESP into EBP. So in a sense, what's going to happen is logically, EBP is going to be pointing the same thing as pointing to here in terms of the stack. So if we refer to EBP, we're referring to the same address here. And so if we start going up from EBP, we're referring to within the stack. So that makes a copy of ESP into EBP. Now this, because of the write string that's taking place here, we want EDX loaded with the address of the string to display. Well, if this is the top of our stack, then 4 bytes higher is this value. Another 4 bytes is this. 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 And then another 4 bytes is this. 24. Okay, so this part right here, the stack pointer plus 24, is what has the pointer to the prompt. And so what we're doing is we're loading into EDX, EBP plus 24, we're loading in this value into EDX, and then we're calling the write string, so that enter the length of rectangle is what will get displayed on the screen. Now this readDEC, remember readDEC will leave in EAX the value the user enters. So if the user enters 12, well, the value that was there gets overwritten, and now we have 12 in EAX. We want to take that 12, and we don't want to stick it into memory. And so what we're going to do is we're going to have EDI be a copy of, well, EBP plus 20, EBP plus 4, 8, 12, 16, 20. That's this thing right here. So it's the pointer pointing to this length rectangle. So EDI is going to get a copy of that pointer. And then the next line, when we say take what's in EAX, which is 12, move it to what EDI points to. Well, since EDI has a copy of this, which is pointing here, then the value in memory is going to get overwritten with that. Now the return statement, so up to this point, whenever we did a return, it just returns control back to where we came from. But because we pushed 8 bytes onto the stack before the call statement, what the 8 here at the bottom will do is, now remember this is from the call, this is saying where we're going to come back to, and what that 8 will do is we'll get rid of the 8 bytes after it. So what the return will do, well first, at the return, these things are popped off the stack and going back to the same place they came from. So EAX, so the value that's here in the stack is going to go into EAX. Because of this pointer here, this gets removed from the stack, we'll return control here, and because of this 8, these things will come off the stack. So on this one fell swoop, all of that, now technically that stuff is actually still here in memory, I'm not meaning it's in the stack, which is why if you really put something onto the stack that you want other things to see, you really should scrub it. But I'm not showing the scrub here. Let me just go and okay. So now after that call, I'm sorry, after this return, we're now going to advance to the next statement after this call. And so that's how the stack can be used as a set of parameters. So we do pushing onto the stack before the method we call, or the procedure we call. Within the procedure, then we have to refer to the correct byte offset to where we are in the stack. So we have to be mindful of everything that goes onto the stack. So the initial call goes on the stack. If we have a number of uses, those goes onto the stack as well. It also means if someone modifies this procedure and adds another register to the uses clause, these numbers would actually have to get updated. So there is some overhead, or there's some things we have to be mindful of. But that is how the stack works. That's good enough. No, it's not.